Okay, guys, this is the second video. We're talking about topic number 2, which is how to use a graph to locate relative maximum and minimum values. First, let's define what we mean by maximum and minimum values. So a relative maximum, relative meaning, relative to the points around it, and not for the whole function overall. Relative maximum of a function is a point. And, typically we give the maximum as a coordinate with the x and y coordinate, although some people kind of use it loosely to say relative maximum is just the y part of a coordinate. But our answers are going to be written as points. It's a point on the function that's higher than the points immediately to the left and right of it. So it's higher than points to the left and right. And, that's how I think about it. But technically speaking, it doesn't actually have to be higher as long as it's at least as high. So if you look at the formal definition down here, let's relate what we just read to the formal one down here. So it says a relative maximum. It comes from, first of all, you have some a value. This is a x coordinate, right? The x coordinate of the function is a, and the point a, comma f of a. So f of a would be the y position at a, right? It's a relative maximum as long as there's some open interval x1, x2 containing a, such that the y value that you just figured out is bigger than all those other guys for everything within that interval. So that's basically this is just a mathy way of saying what I already wrote over here, that if you look to the left and right of that position, then it's at least as big. And earlier, I said at least as high. It's because if you look at this inequality symbol here, so you look at this inequality symbol, you see this little line on the bottom, that means it could be equal. So I said if it was only greater, that would mean it has to be higher, but the equal sign on the bottom means it could also be just the same. So what does it look like? Here's a picture real quick. Something like this, right? Relative maximum occurs when here's the point a, comma f of a, where this function is f of x. Yeah. So you look at this point. If I go to the left, it's higher than everything to the left of it. If I go to the right, it's higher than everything to the right of it. And now, what about this little equal sign? Well, it doesn't have to technically be higher. It could just also be the same height. So it could have something that's like flat like this, and then still all these points would be considered maximum because they're not lower than the points around them. Okay, so once you have that concept in mind, when you move on to the relative minimum, it's going to be the same idea, just in the lower side instead, right? It's going to be the same thing except on the bottom instead of the top. So what is it? Let's look at it in a different color. Relative minimum, it's again a point that's lower than the points immediately to the left and right. And again, technically, it doesn't have to be lower as long as it's at least as low as the points around it. Okay, what's the technical definition? So you have some coordinate right here. You have some x coordinate that's a number a, and then f of a. So a, f of a, and it's inside of this interval. Within that interval, everything around it, every x, is smaller. Like the y value for every x around it is I said that backwards, guys. It's bigger. So let me repeat what I said because I messed it up. So every y value for the associated x's around the area are bigger than the thing that you're looking at. That makes the thing you're looking at a minimum. So the picture here is something like this, right? Here you got your a, and by the way, here's the interval. Here's x1, here's x2, and your a is somewhere in between them, right? So if I look to the left and to the right, everything else is higher, or at least a is not any higher than those. So it's like the low point, basically. Okay, I said a lot of words, but it's really a simple idea. It's just a minimum if things around it are higher, right? That's it. Okay, we call in general these things, whether it's a minimum or maximum, the general term for minimum and maximum, or minima and maxima plural, is an extreme value or an extrema. Two different words mean the same thing. Okay, let's try the questions. So 4 through 8. Again, we're going to do these directly on the paper. So we're looking at the graphs. Number 4 says, look back at question 1. Identify any relative maximum or minimum. Maxima or minima. Okay, so looking back at question number 1. We have a max, and yeah, we got a max right there at that position, right? So maxima or maximum, because it's only 1. 2, 10. That's it. And remember the relative maximum is a coordinate, or it's a point. Although some people, like I said, I mentioned this earlier, but some people just focus on the y value because that's, I guess, the more important one. Okay, let's look at the next one, number 1. So that was, by the way, the only maximum or minimum. There's nothing that's smallest because you can think if I pick something as the smallest, I can just go further down a little to the left. So there is no relative minimum. Okay, now what about this next one? Okay, this one's actually kind of a little bit tricky because you have some points that are both maxima and minima because you got a straight line. So let's look at maximum first. Okay, so if I look at this point here, it's bigger than everything to the right of it, right? And it's at least as big as everything to the left of it. So that means this point right here, 4, 3, that is a relative maxima. What about this point in the middle over here though, or here or here? Any of these points along this line? Well, those are also considered relative maxima because they're at least as high as everything to the left and right of them, right? All the way up until you get to this point, -1, 3. That one is not at least as high as the points to the left of it, so we can't include that. But up until that position, we can. So how do I write that in general? So maxima, this time is plural. So it's anything of the form x, 3, right? So any of these points in this region, x, 3, in the interval. So remember, not including that that -1, but we are including this point because that point is a maxima. So that would be -1, 4, and this time we include the 4. So close bracket. Okay, some people will actually say this a little differently. They'll say -1 to -4, and then they'll also include as a separate point that. Oh, I'm sorry. Wait. I wrote that wrong. I guess. No, I know. I was right. So they'll say what I just said from -1 to 4 with the open bracket, and then they'll say later they'll say the point 4, 3 is also maximum. But that I think that's unnecessary. I feel like that's extra work. So let's just leave it as our relative maximum. Our maxima are everything of this form. Some x coordinate, 3, as long as x is between -1 to 4, including 4. Okay, that's the maximum. And minima are going to look very similar here. Because if I look at this position here, that's a minimum, right? It's less than things to the left. And it's at least as small as things to the right. And then all these guys are at least as small as things to the left and right of them. Until you get to this position, 4, 3 is not smaller than things to the right of it. So minima is going to look very similar to the previous answer, minima. Anything of the form x, 3 again, but this time in the interval. So I want to include this point here this time, right? So -1, including the -1, all the way up until 4, but this time I don't want the 4. Yeah. So then when I say anything of the form x, 3 in that interval, that means I get things like -1, 3, for instance. I get things like 0, 3. I get things like 1, 3, or 1.5, 3, all the way up until 4, 3. Right? These are all points that would be of this form in this interval. Okay, but that's just extra explanation. I don't need that in my solution. All right, so here's the solution, guys, right? What I just wrote here. This is the solution. Okay, but I'm going to move it out of the way now to make space for the next question. Okay, next question is to redo number 3, looking for maximum min again. This one I think is actually easier. It's more obvious. Maximum right there and right there, right? It's pretty clear just looking at the picture. Maxima, there's 2 of them. -3, 4. And these are local maximum or relative maximum because even though, look at this, it's not the tallest thing in the function, but looking to the left and right of it, it's the tallest around its area. So -3, 4 and also 2, 5. And there's one minimum. I'm going to just keep the same minimum. I'm going to keep the same color because it's only an easy one. Right there, right? That position right there. And what is the coordinate? It's -1/2, -2. Great. That's done. That's numbers 4, 5, and 6 done. Sweet. Okay, so now I got 7 and 8 to do, right? So let's look at 7 and 8. It says, for the given functions, determine the domain range, intervals of increasing, decreasing, constant, and extreme. Okay, so more work to do for these guys. I'm going to go to a smaller pen. I'm also going to erase this stuff because it's getting distracting over here. Okay. Okay, so what was it again? Domain range, increasing, decreasing, constant, and then the extrema. Okay. So basically redo the same thing we were doing earlier, plus the domain and the range. Let's start with domain first. Well, how about this? Let's do the domain on the left. Get out of my way. Okay, domain we'll do on the left of the graph, okay? And range. So domain first. So the domain is all the possible x values, right? So looking at my picture here, this is for number 7, this graph right here. The farthest to the left that it goes is -3. Here's -3 right here, right? And it's not including because this is an open circle. So that's going to be -3 on the left. And then everything in between, 0 is also included because there's a point there. And then to the right up until I get to +3. So -3 to +3 is the domain. Okay, what is the range? Okay, range, remember, is the possible y values, but there's actually only 3. This point, and this point. So in a case like this, where it's 3 distinct values, interval notation is kind of weird. I wouldn't even use intervals. I would just use sets here because there's 3 distinct numbers, right? It's -2 or 0 or +2. Those are the 3. Oops, sorry. And here there's this fancy curly brackets, which you can find on your keyboard. Those are to indicate that you have a set. And the set is just a single element in this case. Okay, if you did want to use interval notation, I guess you could write something like -2 to 2, like that. 0 to 0. Or, oh, I'm sorry, -2 to -2, I mean 2 to 2. Just each of those individual points means the same thing. Okay, that's the main range, increasing, decreasing. It's never increasing, never decreasing. But where is it constant? Where is it constant? Okay, from here to here, it's constant. From here to here, it's constant, right? And from here, it's not, it's a single point, so it's not increasing or decreasing or constant. So no increasing or decreasing, just constant. From -3 up until 0. And also from, from 0 up until 3. Notice we excluded the point 0 because at that point, it's not constant, right? So I go from looking at this point to the left and to the right, it's not the same, right? If I go to the left, it's one thing, but if I go to the right, suddenly it's not. It's got this big, huge drop off suddenly. So you can't say it's constant, increasing or decreasing at the point 0. Okay, now for minimum and maximum. Okay, this is an interesting question. So these points are all maxima, right? But if I look at them, they're also minima because they're at least as small as the things to the left and to the right of them, right? So minima. I'm going to say minima and maxima. Both. It's both. Everything from here to here, right? Those are all minima and maxima. And everything from here to here, also minima and maxima. What about the point in the middle? Well, if I look at the point right at 0, this guy is less than the things to the left of it. It's bigger than the things to the right of it. So that one is not included. The center is not included. So just everything in the open interval to the left and to the right. So how do you write that? Kind of like we wrote before. Is everything of the form, so something, some x, comma, 2 on the interval -3 up until 0. That's both a minima and maxima for all of those points. And also at minima and maxima, everything of form x comma -2, I'm just going to write on, from 0 to +3, not including 0, not including 3, so it's open. Right? So, okay, sweet. Put that out of the way. On to the last question, number 8. Last question for this video. Okay, so first, domain and range. Domain, let's clear all this stuff so we don't get confused. Because you can always go back and rewind the video if you want to pull it, make it up here again. Okay, so let's start with domain and range. Oh, these guys are starting to peek in. Okay, domain is everything that the x could be. Looking at it, it goes forever to the left, right? It looks like there's a hole, but it's filled in at this position, so there's no actual hole. It goes all the way here. Okay, so okay. And then right over here, looks like it's going to be an asymptote, but I have a defined point right there in the middle, so that covers the point I'm missing. And then I get all the points from there onwards to the right. So domain is everything. -infinity all the way to infinity. Okay, what about the range? Okay, well, range could be as low as I want up until this position. Okay, as low as I want up until this position. Over here, I'm missing something in my range, right? If I just try to look at it like a up and down values, there's nothing in this level. There's no point where I have a point in this along this horizontal line. So I have everything -infinity up until I hit, what is that? What level is that? That's 2, yeah? Yeah, that's 2. So that means the range would be from -infinity up until 2. I don't get 2. Then from 2, I get more points, okay? So I get, okay, onward, upwards, up till this line, and then I have this point defined there. I get everything from that point onwards up forever. So that means the range is from -infinity to 2 and from 2 onwards towards infinity. I get every possible y value at some point, like everything that's really close to that position, I get there eventually. I just don't have that one spot here. Yeah. And then I have this point covered at 3. So that's the range. Okay, now let's go on to, what is it? Increasing and decreasing next, right? Increasing, decreasing, and then extrema. Increasing, decreasing, constant. There's no time where this one's constant. Let's do increasing first. Remember, you're reading from left to right. Left to right. So am I increasing? Left to right. So following this is decreasing this whole thing, right? Decreasing, that's not good. Decreasing as I go from left to right. So it looks like there's no increasing areas. Okay, what about constant? Nothing constant. There's no horizontal lines. So now I'm looking for increasing. I'm sorry, I meant decreasing. Decreasing. Have I been saying it wrong? I'm sorry, guys. There's no increasing. There's only decreasing, right? So as I look from left to right, okay, left -infinity up until this point right here where I have the gap, it's been decreasing. And then I have a little gap there, right? And then from there on, decreasing again till I get to here. And then there's a little hole. And then from this point onwards to there, it's decreasing again. So I got all decreasing, but in 3 different segments. So I think I did that on the right side last time, right? I'm going to do the left this time because that'll give me more space for the next part. So it's decreasing from negative infinity up until I hit this hole, right? Negative infinity up until 0. And then from 0 onwards, starts decreasing again up until, what's this point? 3. And then from 3 onwards, starts decreasing again. So from 3 to infinity. So decreasing on all those intervals, almost everywhere except for those couple gaps, right? The hole here where it skips up there, and then this position where it's disjointed from the rest of the graph. Okay, now onto, there's no constants, so onto maximum and minimums, extrema. Okay, let's do maximums first. So maximums. Okay, looking at this portion of the line, this thing is, there's no maximum to the left because this thing is going up and up and up. So there's no spot that I could pinpoint as a maximum. And from here it's going down, 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 down. There's no maximum either, except for this point right here. That one is a maximum because that's, if I look at this position here, this little point, to the left it's bigger, to the right it's bigger, right? So I do get a relative maximum right there. I've been forgetting to say relative, but it's understood. Relative maximum at the point 0, 3. Now what about minimums? Okay, is there anything that's lower than everything else? No, because if I try to pinpoint something that's lower than everything else, if I go a little bit to the right, I would be even lower. So I can't pinpoint something that's lower over there. Same thing over here. What other candidates do I have? This looks like a candidate for something, right? But if I look to the right, things are higher. If I look to the left, things are lower. So it can't be a maximum or a minimum. That's it, just the relative maximum, 0, 3. That's all you got. And just like that, guys, we're done with this video. So I'll see you in the next one.